Welcome everyone on this session on space transportation. While thinking about sending an object to space, you may want to consider how you will get your spacecraft into space. Therefore, you need to ask yourself a few questions. Where do you want to go? How are you going to get there? And who will get you there? At the end of this lesson, you should have an idea of this main aspect to consider while procuring a space transportation service and where to find the information for that. What is important to know is that in space, due to orbital mechanics, your spacecraft will orbit around the Earth. There are three major orbits you need to know: LEO, low Earth orbit, MEO, medium Earth orbit, and geostationary orbit. LEO is from 0 to 2,000 kilometers. In general, you have Earth observation satellites in this orbit, for example, for your METEO. Then you have medium Earth orbit, from 10,000 to 20,000 kilometers. Here you have a few constellations like the GPS, but also Galileo and Beidou. And finally, you have the geostationary orbit at 36,000 kilometers. This orbit is special as it allows the satellite to be always looking at the same area region on the Earth. This orbit is highly regulated, and there are some processes at the ITU, International Telecommunication Union, to take into consideration. On this animation, you can see the different orbits. Here you have the low Earth orbit with the ISS, Hubble Space Telescope, and the Iridium satellites. You have medium Earth orbit with the GPS, the Galileo constellation, Beidou, and the GLONASS. So these are the four global navigation systems. And then you have the geostationary orbit, as I mentioned, and you can see here that the spacecraft orbiting is always pointing at the same place on Earth. Now that you know where you want to go, you need to decide how you want to go there. In rocket science, we talk a lot about the delta V. Delta V is the rocket velocity change in meters per second. The delta V is defined through the rocket equation, which is a function of the gravitational constant, the ISP, rocket specific impulse. This value describes how effective is the engine. And then the function on the ratio of the original mass on the final mass. This ratio is important as the mass of the vehicle is in constant change and you are burning a lot of fuel. This equation is for ideal conditions. It does not take, for example, aerodynamic losses or thrust vector misalignment. So the rocket equation is the delta V is equal to the gravitational constant times the rocket specific impulse times the logarithm of the ratio of the initial rocket mass on the final rocket mass. This was the basic physics of the rocket. Now I'd like to introduce to you to the general categories of launchers. You have the small lift launch vehicle with the payload mass up to 2 tons. And for example, you have the Vega launcher. Then you have the medium launch vehicles with a payload mass from 2 tons up to 20 tons. An example is the Soyuz launch vehicle. Then you have the heavy launch vehicle from 20 tons to 50 tons, and the super heavy lift vehicle with a payload mass more than 50 tons. We will see some examples on the next slide for those two launch categories. On this slide, you have different examples of launchers. For the heavy launch vehicle, you can see, for example, the European Ariane 5 launcher, also the retired Space Shuttle, and also the Falcon 9 from SpaceX. And then you also have the super heavy lift vehicle with the payload mass for more than 50 tons. You can see, for example, the Falcon Heavy from SpaceX, but also the famous Saturn V, which launched the Apollo missions. And the current launchers in development for exploration missions such as SLS and the Starship. But at this point, you will ask me, how do I do if my spacecraft does not fill the whole payload capacity of the launcher, or if I want to spend several spacecraft at the same time? Then I will answer to you that you can use a payload dispenser or you can use space tugs. This is a new tendency in the space sector, and I will present to you now a few options. What are the rideshare options? On this slide, you can see 3 examples of payload dispensers. On the left side, you see the payload dispenser for the OneWeb satellite with 34 satellites launched from French Guiana using the Soyuz launcher developed by Space. Here in the middle, you can see the payload dispenser for 60 Starlink satellites that was launched in May 2020, for example, from the Starlink constellation operated by SpaceX. Then on the right, you can see the SSMS, Small Satellite Mission Service, developed by the Italians to be launched with the Vega launcher, that accommodated 53 satellites. You can see that the 3 platforms accommodate several satellites. Another option is to use also the last mile services or space tugs. Some companies here, such as for example Momentus, are developing platforms that can offer to you 2 types of services. On one side, they can service several customers and bring them to their specific orbits. And the other time, you can also procure your launch, and then they will put your, here in this case, your 2 spacecraft into your wished orbit. Momentus is a US-based company and is one of the promising actors in the field, as well as D-Orbit, which is also an Italian-based company. And you have other interesting actors as well, such as Moog, Spaceflight, and Skyrora in the UK. As you can see, the sector is very dynamic, and I'm sure that at the time you are watching this recording, there will be new actors. Finally, when launching a payload to space, you need also to consider the payload environment at launch. Launch is a rough event, and your spacecraft need to survive the couple loads with the launcher or your space tug, the shock vibration at the separation, the acoustic, also to be electromagnetically compatible with the launcher and the other spacecraft. You should also consider the thermal environment in space, but also before the launch, especially if you're launching from a very hot area such as French Guiana. Consider that there will be also some venting around your spacecraft during the launch. All this information are available in the user manual, and they are very critical. So I would really strongly recommend you to check as early as possible this information in the launcher user's manual, and to plan also the according test for the payload environment. And finally, you may also want to consider the side services that your launch service provider offers to you, such as the capacity to perform mission analysis, to really understand where you're going to be specifically delivered, who is going to perform the test for the payload environment, and how the launch service provider is going to verify these aspects. Those tests can be very costly. How and when your payload is going to be integrated into the launcher, and when is the last moment you will have access to your payload, also physically, but also remotely to perform some checks, to do some battery charging on your payload. And last but not least, when is your launch service provider able to launch your satellite? So to conclude, we've been answered the question, where to go, and I present to you the main orbits. How to get to space, who can get your spacecraft to space, and I've presented you the main launcher categories and presented you a few options. And what are also the services around launch? This introduction makes you aware of a few technical points you need to take into consideration when planning to send a spacecraft to space.